Welcome back to the second lecture of BFS algorithm that we were discussing. For the first lecture, you can refer the first video. Link will be provided in this video and in the description below. So as we discussed in the previous lecture, that we'll be discussing the algorithm and with an example. So in this example, we'll be discussing this algorithm. So this is the algorithm for breadth first search, BFS, where we are using a queue. So you can see we are using a queue here, which we have mentioned it as queue. So keep a note that every this queue, this visited array and all such variables have been defined globally, right? So we are not keeping in mind the declaration of the variables. This is just an algorithm where you'll be passing a vertex and a vertex node or anything, and it will be like the BFS sort traversal will be starting from that point, as we discussed in the previous video. So we have taken this graph as an example. It contains, as you can see, 1 2 3 4 5 6 7 8 vertices. Thus now you can understand that this is the algorithm, the function v. So we are passing v. Suppose we are passing v from here. So initially v is a and we are passing BFS at this point, right? At this point we are passing. So first we are taking the value of v inside a local variable u, and we are going into a loop. A loop is represented by repeats and such simple methods in an algorithm. So as you can see, we are getting inside a loop, inside the repeat block. So now you have to consider, like I'll tell you what is a visited array. A visited array, as we discussed in the previous lecture, like there'll be an array that will keep track of which vertices we have visited and which are left to visit. So as you know, here are only 8 vertices, so we need an array of size 8. It will be enough, right? So cancel this out. So I'll just mark this from 1 2 3. You can mark it from 0 as well. That's simply your choice. I'll mark this from 1 2 3 4 5 6 and 7, and oops, I needed 1 here, right? Okay, so I am going wrong with the counting, right? Okay, so we have 8 places here. This is the visited array, and the visited array, you can assume that the visited array is initialized with 0, right? So that indicates that none of the vertices are visited. Okay, that indicates that none of the vertices are visited initially. Now what happens is that let me just clean off this part. It might be like disturbing. Now we'll be going to the next part. So we have initialized u as a local variable and assigned v to that. Now here's a loop. As you can see, that it says for all the edges, all the vertices w adjacent to u, do this. So initially, what is u? Initially the value of u is a, and that point, what will be the value of w? The value of w will be, that means you have to just consider what are the adjacent vertices of a. They are b, as you can see, b and c. So these will be b and c. so the loop will run twice for B and C. Now if visited of W is 0, so if visited of W, which means B, which is actually 2, if the vertices are numbered like that, if the visited of 2 is at 0, it says that no visited of, okay, so firstly don't misunderstand A and B. A is the value here, and these vertices are actually numbered as 1, 2, 3, 4. Okay, for your simplicity you can consider it like this, right? The vertices are numbered like this because the vertices are containing somewhere in the memory, whether it's an adjacency list, an array, a linked list, whatever it is, they are numbered somewhere, right? Even if they're not numbered, they are organized in such a fashion. The value contained can be A, B, C, D, so I have just written that. So what is B? Visited of W, which means visited of B, that is visited of 2 is 0. Yes, visited of 2 is 0. So what they do, add W to the queue. So we have to make a queue here. So let this be the queue. Right. So add W to the queue and make the visited of W 1. So we make this 1. Okay. Don't you think we have missed out something? Ask yourself. We have visited this node, but we have not marked it. So once you're starting from this, you have to mark it that it's 1 here. So that has to be done outside this algorithm, because if you're doing inside this algorithm, every time BFS is called, it will mark the first place as 1, but you don't want that. So you will mark the starting position and the visitor of that outside the function, and the visited is a globally declared array, same as the queue. Queue is also a globally declared array, yeah. And so you have visited B, right? Now you go to C. So okay, so you adding B to this queue, you go to C. C is visited or not? C is not visited. Thus you add it to queue first and make it 1 here, right? So this loop comes to an end here. Now they're checking. So once you're done here, you're now done here, you're coming out of the loop because this W is finished. So it's checking if the queue is empty. Is the queue empty? This queue is not empty, right? This queue is not empty, so this will not return. It will go to the else part. It will delete the next element from the queue as U. As I said in the previous video, how do we delete elements from the queue? We follow first in first out. So what is the first element inserted into this queue? It was B. So what will the first element going out of this queue? It will be B as well. So consider, okay, so it has told that delete the next element from the queue as U. So U will be B now, right? And it calls itself again here. So this time the BFS will be applied on U, which is B. Now for B, what are the adjacent vertices? For V, the connected vertices are A, D and E. A, D and E, right? Thus it will get inside this if checking condition. Inside this if checking condition, it will check whether visited of W is not. So as we were doing this, yeah, so visited of so now first we are checking A gets into that loop condition, right? So visited of A, that is visited of 1 is 0. No, visited of 1 is not 0. That means A is already visited. This condition basically checks if unvisited, right? If the node, if the neighboring vertex is unvisited. That's what this checks. So you go to that. If so you don't get into this, it goes to the next one, that is D. Is D unvisited? Yes, D is unvisited. That is, visited of 4 is unvisited. Thus you mark it 1. You add this to the queue, right? Now go to E. E is unvisited. Yes, add this to queue and mark it 1. End of loop. You come to this checking if queue is empty. No, queue is not empty. Thus what you do is delete the next element from the queue as U. So you delete C this time, B was deleted previously, and you call it as U. So you're now calling BFS on C. This time what will be W? W will be the neighbors of C, that is A, F and G. A, F and G. Similarly, A is already visited. It will visit G. It will visit F first. Now see, it can visit both F and G. According to the implementation of your code, it can either visit G first or visit F first. It does not really matter, because it will depend how you have accepted the data from the user or the system, or how you are designing the adjacency matrix or adjacency list. If F is after G, then it's okay. If F is before G, then it's okay. This is this case, right? So it doesn't matter at all. If they're at the same level, that's it. So same level as in same distance, right? Same distance, like F is at one distance from C, G is at same one distance from C. So it doesn't matter how are they in the order doesn't matter in this case. So A is already visited. It goes to F. F means 6. 6 is marked 1. 6 comes inside the queue, is inserted in the queue. Then you go to G. G is inserted in the queue, and G is marked 1. And the queue is not empty. U becomes D. Delete it from the queue. And W for U is B, which is already visited, and H. So W is B and H. B is already visited. H will be added to queue, right? And this will be 1. So now you can see all the elements are visited, but all of them are not explored. So how do you understand which ones are explored? The ones that are deleted, that contain a 1 here and are deleted from the queue, are explored. So B, C, D are explored, right? That's why we can like print the order here, that the explored vertices can be like B, obviously A before that, then B, then we go to C, then we go to D, right? Because D is like pushed out of the I'm sorry, it should be popped out of the queue after that, after C. So that means D gets explored completely. While exploding D out, right? While exploding D out, okay. When is D pushed out? Just before exploding. So we push out an element and then explode it, right? And this array means that the vertices are visited, right? So for D, H is marked 1. Then once D is completed, we go and delete E. So U is E now. So both the vertices are visited. We delete E, it goes here. This is the order, right? This is a visiting order. This is a visiting order. And then once F is popped out, we pop out G. Again, both the vertices, both the neighbors of G are already visited, so there's no point. Again, we go to H. All the neighbors of H are already visited according to this vertices array. and finally once everything is popped out, we find that queue is empty. So this is the first time this if condition works, and we return. So as we return, we exit of this, we get outside of this what do you say, recursive function. So I'll ask you something, where is the recursion call happening? Okay, so recursion call, pause the video and you can think, right? So I guess you thought. So the recursion call is happening when we are calling back, like we are deleting the next element from the queue and calling u here. So you can simply write BFS of u here, right? So it will call back BFS here, and this is a different version of u. Since this is a local variable, this value of u will be passed on to this u, right? And this will continue until you're returning from that. Once you return, you just go out with this visiting order. Now for this visiting order, you can print this visiting order somewhere here, like you can put a printf and print what is being deleted, right? Or you can just print it here. It's better to print it here, I guess, because you're visiting it, right? So once you mark it visited, you just print that node or vertex, whatever, right? So you print that and you get the visiting order here. So this is how you execute the BFS algorithm. I hope you understood. In case you face any doubt, you can comment below in the comment section. In case you liked the video, in case it helped you before your exam, please don't forget to hit a thumbs up. It will be a great help, and keep watching. You can also comment like what kind of topics you want to know, which you need help. So we'll try to upload that, we'll try to work on that. So that's all for this video. We are ending BFS here, and for any queries, doubts, you can ask anytime. Please don't forget to subscribe and like and share as well with your classmates. Thank you guys.